this section, it's factoring special quadratics. The first one we're going to look at is called difference of squares. You're going to really need to know this one. Comes up all the time. What you're looking for is two groups, right? Those terms can have anything that's multiplied. So you can see here, that's 9x squared. That's still one term. So we know it's one term and one term, so two terms. Terms are joined by multiplication. So two terms joined by multiplication, right? So one term and one term. 9x squared is one term, 25 is another term, with a minus in between. So that's what the word difference. Each one of these has to be a perfect square. So when it says squares, that's a perfect square, and that's a perfect square. What's a perfect square? A perfect square is like 3 times 3, 5 times 5, 4 times 4, 6 times 6. So perfect squares are numbers that can be multiplied with themselves. So does that make sense? So 5 times 5, 3 times 3, 4 times 4. Here it is 6 times 6, 11 times 11. This is 2 of the same bracket. That's a perfect square. X minus 3, that's a perfect square. Y times y, these are all perfect squares. So perfect square, perfect square. So here we've got perfect square, perfect square. So what ends up happening here is that you're going to take one of each. Okay, so I get two brackets. So just like our normal factoring, we have two brackets. We're going to take one of the x's and put it here, and one of the x's and put it here. So break it up, one in each, evenly split, x times x. Then you're going to break up the 16, and the 16 is actually 4 times 4. 4 times 4, perfect square. So you see how it breaks up exactly evenly into each one. Same. And then in the brackets, one of them is minus and one of them is plus. The reason for this is because before, when we learned how to expand these, okay, and I'm just going to do my check, right? So a check is just kind of optional if you want to check it. And if you want to check this, what happens is that you get x minus 4 times x plus 4. When you do your FOIL, first outside, inside last, you go first times first is x squared. Outside one's x times positive 4 gets me positive 4x. Negative 4 times x gets me negative 4x. And negative 4 and positive 4 gets me minus 16. What ends up happening is that these two, because they're exactly the same bracket, except for the sign in the middle, these two end up adding to be 0. Positive 4x minus 4x, 0. So then that middle term we say cancels out, and you're left with x squared minus 16. So this only works when they're identical brackets with opposite signs. Then it becomes this, it's called the difference of squares. So when you see this, you can go backwards and factor it. So we want you to be able to see that this is a perfect square. It can be broken up by 3x and 3x. 3x and 3x is 9x squared. This is a perfect square, so 5 times 5, and then you switch the sign in the middle, minus plus or plus minus, as long as they're opposite. Opposite. It doesn't matter the order, right? So you can be this way or that way. It's the same, but this exact same bracket, but opposite. Okay, so this is a nice pattern to know when you want to do this every time. So I see two terms with a minus in between it. I can break it up to be 6 and 6 to get the 36, and p to get the p squared, and the sign in the middle is opposite, minus plus or plus minus, and that's it. This one you go, oh no, it's not perfect, but what should you always do first is common factor. So before you start any type of factoring, how come I didn't do it here? There wasn't any. No comment, but here I can definitely see a 2. So then you write down 4. Sorry, it's messy. 4, 2 comes out from the 8, 4 minus 4x squared minus 9y squared. So I took out 2 from both, and look, that's a perfect square, right? Perfect square means it can be broken up. 4x squared is 2x, 2x. That gets me 4x squared. 2x, 2x, and this is 9y, so it's 3y, 3y, right? 9y squared is a perfect square, 3y, 3y, and you put 1 minus and 1 plus. Doesn't matter the order of the minus and plus, it can go backwards or forwards, as long as I see one of each, opposite signs. Try it again. 121b squared. 121 is actually 11b and 11b. That gets me 11 and 11. This a is a times a, and the sign in the middle, one's minus and one's plus. Doesn't matter the order. Okay, we're going to look at the bracket ones next. So these bracket ones here, it's the same thing. Okay. You can use round brackets. Sometimes I go, you know what, it helps me if I do a square bracket just so I can see it better. So I'm going to switch them to square. You don't have to, but sometimes it visually helps you see. So this is a perfect square because you can do one of each. Look, one of each. X minus 3 times x minus 3 is x minus 3 squared. Then the y is a y times a y, and the sign in the middle switches. I don't want double brackets, so simplify the extra brackets away. Okay, so here I don't have anything to multiply in, so I'm going to get rid of that bracket. So see how I had square? I'm going to switch it back to round. I'm going to get rid of this extra bracket because nothing was happening with that. But I like it sometimes so I can see what the perfect square was. So here I just got rid of the brackets. And then there's nothing left, no extra brackets, and now you're done your final answer. Okay, we're going to do 2 more of that. Okay, again, I'm going to do the square brackets just to emphasize. The 25 is 5 and 5. This, 2 of them. So I'm going to do 1 in each part, 1 in each new bracket, right? So that's perfect square. The sign in the middle, one's a minus and one's a plus. Now, I have to simplify the extra brackets, okay? So I'm going to have to, in this case, bring in the minus. When I bring in a plus, nothing happens. But when you bring in a minus, remember, imagine, if you will, that's like a minus 1. So you're switching the signs. So it's 5 minus m minus 2. This is 5 plus m plus 2. And now finish. Can I simplify more? If you can, in this bracket, you have 5 minus 2. That gets me, right, like terms. Like terms. So in this bracket, I can go 3 minus m and 7 plus m. It doesn't matter the order here, but you never begin with a negative. So this is not negative m plus 3. We never want to begin with a negative. Okay, so we never want to begin a bracket with negative, so 3 minus m is better. Let's try that one more time. I know these last ones are a little harder because of the extra brackets, so one more time. So when I see the brackets already in the question, I go to square brackets. You don't have to, but it helps me picture. There's 2 of this one, so I'm going to go a plus b, a plus b. There's 2 of that one, so I'm going to go c plus d, c plus d. So it's 1 of a plus b is a plus b squared. C plus d, c plus d, c plus d squared. So you can see I broke it up just like I did above, put 1 minus and 1 plus. I don't like extra brackets, so 1, 2, 1, 2. Okay, let's change these back to round. I don't need anything here. This becomes minus c minus d. This becomes nothing around that one, plus c plus d. And then like this question, we want to simplify if we can, but there's no like terms in there, so then we stop. This one you had to keep going, this one we stopped. Try these again, replay the video, try it again, cover them up, and try it again. Okay, difference of squares really is important. You'll use this a lot, as well as all the other factoring. All the factoring comes back, and we use it a lot, a lot, a lot. There'll be another special quadratic coming up in the next lesson.